All right, hello everyone. I'm Steve Joyson with Northeast Metro Climate Action. We are a volunteer-run community organization with members in White Bear Lake, Vadnais Heights, North Oaks, Shoreview, Matamidi, and Lake Elmo. We've been in existence for about 5 years now and been doing monthly events like this. We kept it going through COVID, moving over to Zoom. We're doing some on Zoom and some on live. Today's course is on Zoom. So we're appreciative of the new technology. We also work with our elected leaders and work in the community on different climate action. So we get involved with a number of different things. But our mission is, our primary mission is outreach with events like this, so we can talk to our community members about both the climate crisis and clean energy solutions, which today's presentation falls under that, the clean energy solution bucket. A few notes before we get started on tonight's, just housekeeping. If we have questions for our speaker, Tom Warner, today, you can type those into the chat. There's some I may interrupt Tom in the middle, or we may wait till the end, depending on how things are going. And you may have a chance at the end if you want to ask a verbal question as well. So there you would just type, I have a question in the chat, and we can do that at the end. We have co-hosts tonight. Our co-hosts are Resilient Roseville, West Metro Climate Action, Sustainable Stillwater, and Vote Climate. So thanks to those groups for helping promote this event and bringing some of your members to this as well. I would like to also acknowledge that we are meeting on ancestral lands of Indigenous peoples. We honor their legacy and respect their rights. Our November event will be in just a couple of weeks, November 8th. We have Priscilla Villawatt, who will be talking about fracking for plastics. And she's an expert in the plastics area and environmental and climate, and particularly the climate concerns of making plastics. And that will be an all Zoom event. And that one's at 6:30 p.m., a half hour earlier than normal. So that will be on November 8th. Right, so tonight's speaker, our own Tom Warner, is the senior architect with Haskell, which is a local design build firm in architecture. And Tom serves as the chair of Haskell Sustainability Council and works as the sustainability lead on numerous projects. So we're happy to have Tom on our team, and he's going to share some of his work with us and some broader aspects of the decarbonization in the building industry. So Tom, you can take it away.
Sounds good. Thank you very much, Steve. Again, my presentation is going to be on decarbonization in the building industry. And can you see my screen already?
Yes.
Great. So the first thing I thought I'd mention is the industry has changed significantly over the last handful of years. And what I'm hoping to provide you with is some basic criteria and what has changed and how it's gone about that change. I thought I'd start off with a little bit of history, though, on sustainability. And it goes back. I'm not going to go over the whole history of sustainability because that would take days. But I thought I'd start with a little bit back when in the Industrial Revolution, when human impacts really started to come about to our climate. And the first photovoltaic cell was actually created by Edmund Becquerel back in about 1839. There's some advancements beyond that, but then the first solar cell using selenium coated with gold was developed in 1883. And then a little further down the road in the 1970s, we had a significant energy crisis. And part of that, solar panels really became a talking point, and Congress passed the Solar Energy Research, Development and Demonstration Act in order to make solar viable and affordable and market it to the public. However, and I'm going to point out that at that time, we also saw some passive solar practices become mainstream with publications such as the Passive Solar Energy Book by Edward Mazzaria in 1979. But in the 80s, energy prices dropped, and so the solar growth really declined at that time, and it stayed dormant for a number of years. But in 1990, Kansas City architect Bob Berkebile founded the AIA Committee on the Environment, also known as COTE, and that was really the precursor to the United States Green Building Council, which was formed in 1993. Berkebile was led a conference where real estate developer David Gottfried, environmental attorney Mike Italiano, and Carrier's marketing executive Rick Bertuzzi got together, and then they actually formed the United States Green Building Council, or USGBC as we know it. As part of that partnership, the first green sustainability program, the Leadership in Energy and Environmental Design, was actually established in 1998. And LEED has gone through a number of iterations since 1998. It's now in its fourth version, and they've actually got a version 4 and then a 4.1. The 4.1 version actually was an enhancement to the version 4, which actually helped establish better criteria for projects to meet certain requirements. The LEED program is set up with, it's a point-based system, and it's set up in different credit categories. And those categories are integrated process, sustainable sites, location and transportation, water efficiency, energy and atmosphere, materials, resources, indoor environmental quality. There are some regional priority credits that actually tie back to the location of the projects. And then there's a category for innovation and design, which is where for projects that are looking to go above and beyond what is normal in sustainability. Those would be those types of credits that would establish beast in that area. As I mentioned, it is a point-based system. It's about 110 points, and it's got 4 different levels. There's a certified level, silver for 50 to 59 points, gold 60 to 79, and then a platinum, which is really the top tier, and that's at 80 plus points. One thing I thought I'd mention is that LEED version 5 will be coming out in 2025 in beta for the new construction category. Right now, they've just issued it at Greenbuild a couple of weeks back for the operations and maintenance category, and that's also in beta right now. The LEED program is actually a number of different certification programs. There's the building design and construction, homes, operations and maintenance, interior design and construction, and then neighborhood development. And within each of those are different categories that you can achieve certification for LEED. One thing I thought I'd mention is that the LEED point categories, the most significant point category that is currently set up is in energy efficiency, and that makes up about 30% of the LEED prerequisites and credits. As part of the growth of LEED, LEED has actually kind of pushed the boundaries of the industry, and sustainability standards have been developed to actually support these third-party certifications, and programs such as Energy Star have also been developed, and those types of programs actually either identify or certify products that meet certain sustainability criteria. The Forest Stewardship Council is another one of those that would also provide certification of their products. And as a result of LEED, building codes such as the International Green Construction Code, ASHRAE 90.1, which is a standard, and the same thing with ASHRAE 189.1, those continue to be updated in reaction to the changes that LEED has pushed forward each iteration of LEED. And beyond LEED, there's other certification programs that have also been developed. Green Globes, Minnesota's own B3 program, and the Living Building Challenge. On the government side, there is the Guiding Principles Compliance for both DoD and other government federal programs. Florida Green Building Council is another one that's specific to Florida. And then the Well Building Standard is for interior design as well. The main focus of all of these programs has really been, as I mentioned before, energy has been a significant part of that. Energy reduction has been a significant part of those sustainability programs. And it's really for the reduction in the extraction of natural resources and the reduction in energy use. As most of these projects have now gone through energy modeling and energy use intensity. That's become a staple for all of these projects now. We've looked at building orientation, mechanical equipment, lighting, daylighting, and envelope systems to reduce those energy loads in buildings. And those have really been a significant change in the last number of years.
So Tom, I have a quick question for
Yes.
you. So there's this state of Minnesota has building codes that are statewide, and I think there's some cities that have more stringent building codes. So everything you're talking about here is above and beyond that. And is any of that mandated or regulated at any point, or is it all voluntary?
The LEED is voluntary unless it's been a requirement from certain communities. As far as the ASHRAE 90.1 is really the only standard that the building codes reference. The ASHRAE 189.1 has been referenced by the government, by the DoD in the past, the Department of Defense, but they've now switched to the International Green Construction Code. And that International Green Construction Code is not necessarily mandated by communities unless they've adopted it. And most of the communities have not adopted that just because it goes above and beyond what the other building codes require. Right. So it's really a very sustainable program, but it is based on a lot of the LEED criteria.
Okay.
And one thing these codes and programs had not really addressed in the past is carbon emissions. but energy efficiency really is not enough at this point. We've really got to look at how we do construction differently. So what changed? Well, the climate crisis has really upped the ante a little bit. We've now seen 47 continuous years of increasing global temperatures. Our weather-related events are now becoming more intense. You know, we've got more extreme drought. The wildfires are much greater. We've seen the ferocity of our hurricanes increase due to rising ocean temperatures. We've seen more 100-year floods than we've ever seen. And when we see the oceans rise, the storm surges are just taking out communities. We've also seen an increase in tornadoes. But a couple of the things that I think are even more significant are the melting of the glaciers and polar ice caps. Those are in turn raising the ocean levels. At this point, they're swallowing low-level islands, but in the future, they might actually affect major communities such as Miami. One thing I thought I would point out is the photograph in the upper left is from a photo I took in Iceland back in 2017. The sign that's in there is where that glacier was located in 2010. And it is now receded in 2017 about 1/4 of a mile, and it continues to recede. So that just gives just a sampling of what is happening in with our glaciers and polar ice caps. Just to reinforce the issue on global warming, this is a 30-second slide presentation of the global temperature anomalies from 1880 to 2021. It's based on a normal temperature cycle from 1951 to 1980. And as you can see up in the upper part of that is the years that we're seeing. And as it gets further towards our current time, you can see how the temperatures have increased significantly. So when people say that, it's always been warm and cold, we've never seen this before. This is so far out of what we've seen in the past as far as temperature anomalies. Oops. And let me move that forward. All right. And as a result of these increasing temperatures, the United Nations Climate Change Conference of 2015 issued the Paris Agreement, where they set a temperature increase limit of 1.5 degrees Celsius above the pre-industrial levels. And what they're really stating is we need to have rapid and far-reaching improvements to reach net zero greenhouse gas emissions by 2050. That was the goal, is to get net zero by 2050. And what we're looking at, what happens if we exceed that? Well, first of all, I'll show down in the graph there, that's showing our current warming rate. And at the rate we're going, we will hit that 1.5 degrees by 2040. So we really need to make significant improvement to avoid that 1.5 degree level. And the right-hand side slide will show that what happens if we're hitting that 1.5 degrees. We're going to see a loss of a lot of species, plant species, insect species, coral reefs. We're going to see a lot of our sea ice disappear in summers, and then we're going to have to deal with a lot more extreme heat conditions as well. And we really don't want to think about what happens if we go beyond 1.5 degrees. When we get to two degrees, it's much significantly worse. One of the other things that's been coming out in the last few years is a increase in number of corporations that are developing environmental, social, and governance frameworks, and that's including reporting carbon emissions. Corporations are starting to also require that new construction projects achieve net zero carbon. We're also seeing in the industry, the architect, engineering, and construction firms are now seeing requirements to report our own carbon emissions within our own operations. The Carbon Disclosure Program and EcoVadis are a couple of examples of those carbon reporting frameworks that we would report our own emissions to. Again, it's really the corporations are pushing a lot of this now to decrease the carbon emissions on not only their projects, but our side as well. So how does this all relate to the building industry? Well, the built environment really makes up about 42% of all total global CO2 emissions. About 30% of that is in building operations, and then the remaining percentage of that is from the materials that are put into the building. That's called embodied carbon, and I'll talk about that in just a few minutes here. So our presentation really concentrates here on decarbonization, and the key principles of building decarbonization include energy efficiency, electrification, grid interactive, and then renewable energy. And grid interactive is basically, connecting buildings to the grid through energy management systems. If we've got renewable energy systems, that they would be feeding back and forth with the grid. Also things like demand response as well, for peaks and so forth. We're also looking at ways to reduce the use of fossil fuels, using low carbon fuels. And then again, we talked about in new construction, as part of this decarbonization, we'd also be looking at low embodied carbon. So the two types of carbon that we have are operational carbon and embodied carbon. Operational carbon is anything that's related to the energy consumption and operations of the building. Switching on a light will hit operational carbon. If you got a appliance that you're plugging in, that's going to take operational carbon. Your mechanical systems that are running, that's all operational carbon. On the other side of it is embodied carbon, and embodied carbon comes from the extraction, manufacture, transportation, and construction, in addition to the end use of a material. The main difference between operational carbon and embodied carbon is basically a fixed carbon. We typically would have an upfront carbon, and I'll talk about that in a little minute. But the operational carbon can, from a typical building, would be greater than the embodied carbon. But in a high performance building, we're looking at that being significantly less than what we'd be seeing in the embodied carbon, as the embodied carbon is really a fixed quantity in a standard similar type building. So in operational carbon, for decarbonization from the operations side, to meet our goal of zero emissions by 2050, we'd be looking at highly energy efficient buildings, and those would include building envelopes, mechanical systems, LED lighting and commissioning, making sure that all of our systems are operating properly. Then electrification is another key component of that, and that's no on-site fossil fuels, and that would include things like using electric heat pumps, electric boilers, electric water heaters, and electric appliances. And then additionally to that, we'd be looking at 100% powered by on and off site renewable energy. That would include building level solar farms, wind power, solar hot water, and there's other solutions there as well. So to not only do we want to look at it from the building side, but we're looking at it from the grid side. So if we electrify all of our buildings and the grid can't support it, we've got to, that's not going to work. What we want to make sure is that the grid is also becoming carbon neutral, and the grid actually has become 30% less carbon intensive between 2000 and 2019. We've also seen that 83% of America's new power came from wind and solar in 2021. There's been at least 18 states and possibly more since this slide was produced that contain 45% of the Americans and have committed to a carbon neutral grids by 2050. And Biden in his Inflation Reduction Act proposed a carbon neutral grid by 2035. So those are goals from the grid side. And if we can get that all to work, that'll go a long ways in getting us down to that net zero by 2050. So one of the things that has changed is the cost of power for power plants, and the solar power has reduced in about a decade, a little over a decade, by over 80% in cost. And onshore wind has also reduced by at least 20%. So now those two are the lowest cost for all of the electricity prices for new power plants. This slide is basically showing what the generation has increased within about a decade in both wind and solar. And you can see that wind has just taken off, and solar is going to start catching up as the price of solar has now come down significantly. And now I'm going to talk a little bit about embodied carbon. And embodied carbon is really the greenhouse gas emissions arising from the manufacture, transportation, installation, maintenance, and disposal of building materials. This slide shows the different stages of embodied carbon, and the numbers that are down below, the A1s through C4s, are life cycle stages. And I'll talk a little bit more about life cycle in just a minute. But again, it's the emissions start generating from the moment that the raw material is extracted from the earth, and it continues through to the end of its life. But like I said, there are upfront carbon, and then if we take it all the way to the end of life, that would be a whole life cycle. Between now and 2050, embodied carbon is going to account for nearly half of all new construction emissions and almost 3/4 of all construction-related emissions over the next decade. So it's really important that we address embodied carbon and finding ways to reduce the carbon that's emitted from our products.
So Tom, can you go back to that last slide? Because it's like it contradicts this end of the life phase on the far right of this graphic.
Yes.
That it's only 3 to 15% of embodied carbon emissions. Is that just that specific phase, or is that all the phases combined?
That is just the end of life phase.
Okay,
So what you're saying is in the product phase, most of your total embodied carbon is going to come when you're extracting and manufacturing the product.
the materials, right?
Materials, yes. And then at the construction phase, you've got about 6 to 10%. You know, a lot of that comes from the machinery that you're using to install it. And then we've got you know, into the use and maintenance phase. That's going to be primarily repair and refurbishment. You know, so if you've got things that need to be repaired, any materials that are used to repair things, and you might have like well, in the case of solar panels, that you might have a panel that's gone bad and you have to replace it, so that comes into that use and maintenance phase. So repair and refurbishment.
When you combine all those together, all those phases, it doesn't look like the 75% or whatever you said on for the next slide. If you go to the next slide.
Yep.
It was, yeah, 74% of the total emissions from the construction.
Yeah, this is what we're looking at here is that, and this is kind of a hard slide to you know, this is looking at business as usual. So we're looking at in all new construction, embodied carbon makes up 74% of all the embodied carbon in 10 years. Right now it's at 100%. You know, so if you have a building that's built right now, the carbon is going to be at 100%.
Okay.
As the operations of that building increase, then the embodied carbon percentage decreases.
Yeah.
But
okay.
This next slide might help you with that, hopefully.
That looks good.
So again, here, this kind of points that out. So here you can see that the upfront embodied carbon is significantly high at the very beginning of the project. And it's a one-time thing. But operational carbon continues through the life of the building. You might have, you know, other steps along the way for embodied carbon as you're doing, you know, repair and maintenance. But the operational carbon continues through the life of the building. In this particular slide, we're looking at it as the grid gets greener, our operational carbon decreases. If we stay status quo on the grid, then that the operational carbon stays constant across the timeline. But as our grid decreases, or as our grid gets greener, that number should come down. So how do we reduce embodied carbon? Well, we want to select low carbon materials. Doing whole building life cycle assessment will help us to understand where we've got our major issues with carbon and finding ways to improve in those areas. We can compare similar products, environmental product declarations to determine lower carbon products, and I'll talk a little bit about environmental product declarations in a couple of minutes as well. We can select products with recycled content. In the case of things like structural steel, the extraction of the material, the minerals that go into structural steel is significant. And so one of the things that, from my perspective, I try and specify as high a recycled content in structural steel as possible. And you can look at different manufacturers of steel or different plants. And you know, different plants have different percentages of recycled content in steel. I'd like to see if we can get at least 75% recycled content in all their structural steel components. The industry average, according to the US GPCP and LEED, is 25%. But again, if we can up that significantly, that reduces your carbon footprint. Another thing we look at is reducing or replacing Portland cement in concrete. And then the last one is purchase carbon offsets. So when we're selecting low carbon materials, there are certain tools that we can look at, that we can, quickly look at and judge which ones are going to be lower in carbon for us. This is just an example of one of those types of tools. In this case, you'll see that concrete and steel have the highest what they call total global warming potential, which is another name for CO2 emissions. And that's fairly typical that concrete and steel are always going to be at the high end. You'll also notice in this particular slide that timber, in this one here that's talking about glue laminated timber beams and columns and cross laminated timber sheets. And that the timber is the lowest of the CO2 emissions for structural frames. And the term cross laminated timbers is a relatively new term for us in the industry. Glue laminated beams, we've all seen those in the past. And I don't know if anybody can see me, but glue lams are typically going to be one on top of each other, but a cross laminated is where the each layer is perpendicular to the next, and that forms a stronger bond than the glue laminated timber beams. It becomes more fire resistant, and timber itself is, like I said, it is the lowest embodied carbon product. And if we're looking at ways to really reduce our structural systems, if we can use timber, it really reduces that carbon footprint significantly. There are other tools such as Kaleidoscope. This is an embodied carbon design tool. This gives a quick glimpse of different types of assemblies. In this particular case, we're looking at wall systems, and it gives you kind of a very quick analysis on the global warming potential on different systems. For instance, in a masonry veneer system, the granite is going to be the highest global warming potential, whereas a thin brick system will be the least. If we go down to the curtain wall, you'll notice that the spandrel with aluminum and with the back pan is the greatest. But if it's a spandrel system that consists of wood, again, that's going to be the lowest global warming potential for that particular system. And life cycle assessments are tools that we can use to really analyze the entire building for the CO2 emissions of the building. It'll also look at other environmental impact categories such as acidification, eutrophication, smog, ozone depletion, and then primary energy. In this particular case, this is a project that we did in our office. I'm not giving the name of the building, but I think the criteria is such that you can see under the baseline building, we did an analysis for the baseline and also for our proposed design. And that way we can compare how our proposed design it compares to the baseline building. In this particular instance, you can see that under the product stage, that's the highest global warming potential in both the baseline and the proposed, but our proposed design actually has a significantly lower CO2 emissions than the baseline does.
So Tom, just a couple of quick questions here.
Yes.
Looking at this one, you're saying it's significantly lower. It looks about 10% lower with this proposed building, right? About 4 million, 4.4 million. So it appears that getting the embodied carbon out is really difficult. If
Yes.
proposal and you basically got 10% out, right?
Right. I mean, if it, and this is the reason why, you know, from a standpoint in LEED, they've got criteria for this where in order to get a LEED credit, if you exceed 10%, you're basically maximizing your points for that particular credit.
Okay, so another question was about the granite, why it was so high with the GWP. You know, it's basically you dig it out of the ground and cut it and put it down, right? Or is there more to it?
Well, you've got to polish it, and it's a matter of the extraction is huge to get granite out of the ground. You know, think of the types of machinery that you need to cut that granite. You know, it's a significantly hard surface, and so you're going to go through, you know, different types of equipment to cut that,
Right.
and all of that is high energy.
And I think the question stems from the fact there's no processing step like steel and cement, which the processing of both, you know, from cement from or steel from ore and cement from calcium carbonate has a lot of inherent carbon dioxide emissions just in the chemical process itself.
Right.
And whereas marble or granite is just, you know, you dig it out and you use it. So
let's go back to that slide for a second here. And so what we're seeing here, this again is primarily and I wish I could open up that slide for you, but basically what we're looking at, this is a panel system. And so this is the granite is basically a veneer that goes on over a substructure such as metal studs or something to that effect. And so the granite here is only compared to those other four products. It's not compared to the steel or anything like that. Okay. So your concrete might be significantly greater than granite.
Okay.
I don't have an ability on this one to compare it to concrete.
And the other question, maybe go back a slide on the with the circles on it. Yeah. What's the cost difference on some of these, like, you know, the real low one, like the timber, the steel and hybrid steel and timber, compared to, you know, the traditional materials? Is, you know, we saw a 10% decrease in the GWP. What's the cost? Is there a big cost increase in going to some of these low carbon materials?
Sometimes, yes. I mean, I can't really give you a good price difference between timber and steel. For the most part, you're probably going to require a little bit more in volume in timber than you would in steel, which means that you're probably going to be paying more. But I don't have a good cost per square foot difference right now. But yes, typically what you're going to find is that there will be some increase in upfront costs. But down the road, you're also going to be seeing a potential benefit as well. In the case of timber, it has, you know, some biophilic properties. So in that case, what you're going to be seeing in timber is if you're using it as an element that is also exposed, it has, you know, and I'm not sure if you're familiar with the term biophilic, but basically what we're looking there is it provides for enhancement of indoor air quality.
Okay.
So there's benefit to, you know, the employees.
Sure.
Things like that.
Just wanted to get those questions out there before we got too far past these things.
Yeah, and like I said, it really is dependent on the systems and how it's designed. You know, you can, you know, in the case of steel, you know, how you design your steel framing system, you know, you can change, you know, you can add more columns, you know, you can increase your column spacing and, you know, decrease your joist sizes, or you can, you know, and all of that will change how much steel you've got going into your project, and that affects cost as well.
Okay.
The nice thing about these life cycle assessments is it'll really give you some good ideas of what's happening with your project. And in this particular case, we're looking at the impacts at the life cycle stages. So at the product stage, the A1 to A3, that's the most significant area of global warming potential. And it's really the same for all of the other categories as well. But then you can also look at it from the materials standpoint, is what materials are having the greatest impact on those impact categories, such as global warming potential. In this particular case, we've got concrete and metals as is the primary CO2 components. In this particular project, we've got a steel frame, and we have metal panel walls, and then a steel, steel frame roof. But we also have precast walls up to about 8 feet and concrete slab as well. So you can see the impacts of those two materials are really what's taking over on this particular project. Mentioned environmental product declarations. So what environmental product declarations are they're documents that the manufacturers, there's a number of different types of environmental product declarations. Manufacturers can do their own EPDs. There are generic environmental product declarations that are put out by the industries. And then there are what's called third-party certified environmental product declarations. The list that you see here are libraries of environmental product declarations, and most of these are going to be the third-party certified environmental product declarations. And I thought I'd just show an example of one here quickly, if I can find it. What happened to it? And I'll just go from this one here.
You may need to change your, there you go, sharing screen, there you go.
Got it. All right, so I'm just going to quickly go into, actually, I think I had one over here, if I can find it.
Ooh.
Here we go. So I just picked one out, and this is for just ceiling panels. And so it comes through, it's a long document. A lot of times it'll talk about, the manufacturer, give all this criteria on the manufacturing, who did the, this is an external environmental product declaration. It's been independently reviewed. You can go through the product description, and I'm not going to go through this whole thing, but one thing I thought I'd do is come down to the page that talks about what we'd be looking at is this particular page here, where we can actually see in this product, they do their own LCAs, the life cycle assessments, and we could see what that particular product has as far as the global warming potential of the CO2s for each of their different categories. Then we can take this and compare it to another similar product, maybe from a different manufacturer, and see, okay, who's got the lowest global warming potential. Now that's one way of comparing it. You can also compare for other criteria as well. There's other things that you would be looking at, when you're doing this compare. You'd want to see, what if this got red list products in it, and red list products are products that are high chemical, and those are the types of products that you may not want to have in your project. Or you can look at other characteristics of those particular products. But if you're looking for the global warming potential, this would be the area that you'd be looking at. So again, these would be the different organizations that have libraries of those environmental product declarations. Sorry, I'm trying to get back to my slide presentation here. There we go. So the embodied carbon in concrete is significant. Worldwide, the demand for concrete is second only to water. Concrete is responsible for approximately 50 to 85% of all the embodied carbon in a building. And the cement in concrete makes up approximately 7% of all global CO2 emissions.
Which I'll point out is about 3 times as much as all commercial air travel combined.
Yes.
So cement is one of the biggest carbon emission sources globally.
That is correct. And so what can we do to reduce our carbon in concrete? Well, some of the things we've already been, in the industry looking at. One of the things that has been, significant in recently is replacement of Portland cement with limestone Portland cement, and that'll reduce the CO2 as much as 10%. We're also designing our mix designs with supplementary cementitious materials such as fly ash and slag, and replacing the cement with that with as much as, in some cases, I don't know, 25 to 30% replacement of the Portland with fly ash. And that can reduce our CO2 emissions anywhere from 10 to 30%.
So Tom, there was a question in the chat about hempcrete. Is that something that you've heard of? Adding hemp instead of fly ash?
That might be considered another supplemental cementitious material. The issue with hempcrete is you really have to make sure that it meets all the standards. If you're building a project that has to meet certain ACI standards, you have to make sure that you're able to do that, with the hempcrete. So that's I'm not a structural engineer, so I leave that issue up to the structural guys to make sure that that your mixed designs are meet the standards appropriately. So hempcrete would be one of those that you'd have to look and verify that it meets the ACI standards, which is American Concrete Institute standards. Another relatively new technology is what's called carbon capture, and that's where they capture the carbon up to 100% of the carbon emissions from the manufacture of cement, and then they'll store it in one of those, like in that tank that's in that photo, and then they'll inject it back in to the concrete to strengthen it. And depending on the mix design, you can get anywhere from 40 to 60% reduction in CO2 emissions.
Any idea on the upcharge of doing that?
Some of the companies are actually doing that standard, so I can't think that it's significant. It's now starting to become a little bit, there's a number of manufacturers that are actually, including that as part of their standard mix design. I haven't seen it here yet.
I would think that with a 40 to 60% reduction in CO2, if it's not too expensive, we should really be doing a lot of that.
There right now, I'd say that there is an upcharge for most concrete plants that are using it, and I can't say what that upcharge is yet. I haven't had a project that's actually implemented because it's like I said, it's a relatively new technology and it is in limited areas right now. But it's like I said, it is becoming more popular, and it is it's one of those that I think is really going to take off in the near future. When I was at Greenbuild a couple weeks back, there is another company that is just starting, and they are replacing all of the cement in their particular concrete with carbon. I don't know how that works. I'm still waiting to get more information from them. But that seems so they're telling us that they get zero carbon in their concrete. So in the case of the carbon capture, because all that carbon is sequestered within the concrete, it does not emit into the atmosphere.
So that would be the, in the processing of, forget what they call it, it's calcium carbonate to calcium oxide,
Mhm.
right? To getting clinker. The chemical reaction releases carbon dioxide. They're probably capturing that carbon dioxide. They also have to heat it up to like 2000 degrees Fahrenheit or something like that for that to occur. That part would be harder to capture because that's just energy going in. But I would imagine that the chemical reaction that converts calcium carbonate to calcium oxide reduces carbon dioxide, and that would be where I would imagine they're doing all their carbon capture.
I think so. I'm not exactly sure how that technology works, but if you're interested in that, Carbon Cure is the company that has started this technology. I think there's another one out there as well, but I don't know the name of that one right now. And there seems to be a slightly different version of this one.
All right, Tom, and we are at the 8 o'clock hour, so
I'll just next slide, and that should be it.
okay.
All right. So how do we get to that path to net zero? We've got tracking programs out there. The AI 2030 commitment, where architectural engineering firms are committing to reporting their carbon emissions on their projects. SE 2050 is a reporting agency for reporting our structural systems in carbon. And then same thing with the MEP 2040 for mechanical, electrical, and plumbing systems. The certification programs that are out there are LEED Zero for LEED Zero carbon. They've got LEED Zero carbon, LEED Zero energy, LEED Zero water, and LEED Zero waste. And then, as mentioned before, LEED version 5 is coming out, and that's going to have a more significant concentration on reduction of carbon emissions as well. So that's it for me. Any other further questions?
So we did cover all the questions that were in the chat, I believe. Yeah, it's pretty, and I think we answered Diane's question about what else is in the pipeline. We talked about a bunch of different things there. And yeah. Yeah, so Kate also had a question. As an architect, are you automatically selecting low carbon materials, or are you following the wishes of the client?
Right now, for the most part, we're meeting client requirements. Most of my projects are all Department of Defense projects, and for those types of projects, we are performance oriented rather than project or product specific. So we specify materials to meet certain criteria, and we're getting to the point where we're, in the case of concrete, we're specifying fly ash levels. We're also looking at specifically if it's a LEED project, to require that they provide environmental product declarations, And, we're also doing life cycle assessments as part of that. And, we are looking at ways to reduce our carbon as part of that in our designs.
Good to hear we're using our tax dollars for sustainable buildings.
Yep.
All right. Did
I was going to ask about water, and maybe that your last slide you put up, you mentioned that there's a LEED certification coming along for water. Yeah, I was going to ask about, the amount of water used embedded in the embedded, so there'll be embedded water and functional water or operational water once that those certifications have come through. And I'm impressed with how recently in, your timeline of how all this is developed. I'm impressed with how recently it has developed. And so that's showing a lot of progress in
Yes.
really a short period of time, just a few decades.
Right.
That's very encouraging. But I'm
And-
glad to hear that people will consider how much water is used in manufacturing different.
And I think what we'll probably see, and I don't know what LEED version 5 is going to address with water. We look at primarily when we're dealing with LEED projects, we're dealing with the potable water, and how we're using it, but it's not necessarily what's embedded into the processes. We are into the materials itself. It's more, we're looking at the operational carbon when it comes to LEED. We look at both our potable water use for building operations such as your toilets and sinks and so forth. But we also look at processed water that is used for industrial applications as well, or even like the mechanical systems, condensate and whatever. But it's not been really addressed as far as embodied carbon or embodied water.
Or how much water could be recycled within a building, like processed or cleaned within a building and reused or reused.
Yep. Well, we do look at at this point, I don't have many projects that use like rainwater cisterns, but we're looking at that on many projects. Is can we make it life cycle for, like I said, my government projects, we have to look at life cycle cost as opposed to life cycle assessment. So in the government's eyes, they look at the cost, the life cycle cost of a system like solar. So we always do life cycle cost analysis for solar systems on buildings. We also look at it for rainwater harvesting.
Okay.
Buildings.
Fabulous. Thank you.
Yep.
So I think we have time for one more question. Does anybody else have a question? All right, so I'll ask another one. I'm on the Vadnais Heights Planning Commission, and last year we had the developer of the new high-rise apartment building that's going up on Rice Street and 694. Come talk to us. It's across from Oliver's Restaurant.
Yep, got it.
I proposed to him that they shouldn't put natural gas in that building, and they should make all air source heat pumps and try to make it real efficient. And the developer came back to me and said, no, it's not cost effective. It's too expensive to use those technologies, and they're putting in natural gas. Now, so how are you seeing that with buildings? Are you seeing more and more buildings going up with electrification? Or
electrification is so. One thing to point out is that the government is really stepping ahead on this a little bit. The GSA not this past couple of weeks, but a year ago at Greenbuild, the GSA announced that all of their future construction was all going to be electric, that they were not going to use any fossil fuels. I'm not sure where that's gone, but I believe that that's still the case. The Department of Defense has just issued a memorandum in, I think, March of this year on any further project that's not beyond 35% needs to go all electric. And by fiscal year 26, all of their projects are geared to be net zero projects. We're also seeing, locations out in California and other areas that are requiring all electric.
Yeah,
So
that's good to hear.
it's
Yeah.
pushing, it part of it has to come from, our own local governments to start pushing that, be it in their ordinances. But we're looking at a lot of issues with people wanting to, the gas companies want want to stay alive, and so the lobbying is part of that. So it's part of it is making sure that electric is provided with a good cost, return on investment.
Well, it sounds like advocacy that Northeast Metro Climate Action and our other co-hosting groups are doing is, we need to do as much of that as we can.
That's great.
For policies and code changes to make these buildings greener all the way around. So, so Tom, thanks a lot for your presentation. It was really very interesting. A lot of good information in there. We really appreciate you sharing your knowledge with us on the green buildings.
Thank you very much.
All right. Well, thank you, everyone. And come back in a couple of weeks and we'll have Priscilla Villawatt talking about fracking for plastics and talking about how we can, I think what the harm is in plastics and as far as the climate issue. So thanks again, everybody. Thanks for coming by. And
Good
Thank
night.
you.